Today I have a 40 volt 5 amp hour Greenworks power tool battery, and I bought it on eBay for $30. I don't have Greenworks power tool, but I do need some high discharge 18650 cells, and this is the cheapest way to acquire the cells on the internet. This is 40 volts. That means this battery is a 10S battery pack. 5 amp hour. That means it could be 10 cells of 5 amp hour each, or 20 cells of 2.5 amp hour. And my guess is 20 cells of 2.5 amp hour. This is new and I have never opened one before. In this video I'm going to open it up and tear it down and show you what's inside. I'm also going to test the cells for capacity and also for discharge rate to see how good they are. Let's get started. So you got 6 screws on this side and no screws on this side, and they are Torx screws size T10. The screws are out, but it still doesn't want to come out, and it looks like the sticker, these are holding back the battery pack together, so I have to peel off the stickers also. Alright, the stickers are out. So here it is. We got thick foam insulation on both sides, so let me peel off the foam insulation. And it looks like everything is modular, so you can unplug this, you can unplug that, you can unplug this, which is the battery gauge, and you can also remove the BMS. Looks like it's being held back by 2 screws and also the solder to the terminals. So if you can desolder this and that, I can pull the board out. We've got a 60 amp fuse on the BMS. That makes sense because these cells usually rated between 20 to 25 amps, so total about 50 amp max. So 60 amp fuse makes sense. Let's take a closer look at the cells here. And it looks like they are all scratched up. And this has a little dent on the sleeves here. They don't look like new cells to me. They have model numbers printed right on the cells, but it looks like whoever made this did a very good job of hiding the model numbers. I can't see it in any of these cells on the bottom here. If you look very closely, it's all the way in there, and I can't even tell what that is. And also, judging by the color of the cells, this is usually LG cells. This is the cell that I salvaged from an Apple laptop computer. This is very, very old, but this is the color usually LG used to make the 18650 cells. And I hope these are not laptop cells, because this one here, discharge rate is only about 3 amps, whereas a high discharge cell from power tool battery usually between 20 to 25 amps. Alright, let's take it apart. Let's remove the BMS first. And it looks like I just have to unplug this, unplug that one, and remove the 2 screws, and also desolder this terminal and that terminal, and I can pull the board out. Looks very simple. One last thing, we have a thermal sensor right here, stuck onto the cells down there. It's glued together by some sort of silicone here, and I can see the head of it sticking out right here. So I just need to use a screwdriver and just pry it out. There we go. It's out. This thermal sensor is very important if you want to save the BMS for something else, because without the thermal sensor this is not going to work. Here we go. 10S BMS for power tools. I can use for something else. And here is the battery pack, and as I expected, it has a total of 20 cells in here. So you got 7 on the bottom, 7 in the middle, and 6 on the top. Now I can peek right inside here, and I can read out the model number, which is the top number. I can't show it very clearly on the camera, but let me read it out for you. LGDAHD2C1865. So here's the model number. It's an LG HD2C high discharge cell. So I got good news and bad news. Good news is it's made by LG and it's a high discharge cell. Discharge rate is about 20 amp. The bad news is it's not total 5 amp hour as the seller claims or printed on the label here. Each cell is actually only 2100 milliamp hour or 2.1 amp hour each. So the total capacity is 4.2 amp hour instead of 5 amp hour. Let me pull up the LG data sheet from my phone here. So the cell is LG HD2C 2100 milliamp hour. That's the capacity. Let's zoom in a little bit here. You can see the continuous discharge rate is 20,000 milliamp hour or 20 amp. And I also have another bad news. This cell, I can confirm now that they are not new. You take a look at this one here. You can see it has scratches on the top terminal, and all of them are like that. Okay, so looks like they use a Dremel tool and clean up the terminal before they spot weld it. The reason why I know this, because I have done it myself thousands of times. Here's an example of a cell I salvaged from a Ryobi battery, power tool battery that is. When I pulled it out from the original battery, they always had remnants from the spot welder, and they stick out. And in order for you to weld another nickel strip on the top here, you're gonna need to clean up the surface here, either using a Dremel tool or sandpaper to flatten the surface. Otherwise, if you just weld it on here, it's not going to give you a good connection. And this cell is new when I pulled it out of the Ryobi battery, and you can see on the top surface it doesn't have scratches like what we see here. All of these cells have scratches on the top surface. And another way I can tell they are used, the outer surface of the sleeves of the cells, there are scratches, there are dings, and they look dirty. But at least these cells are brand name LG cells, unlike what we have on the Ryobi battery. These I pulled from a 3 amp hour Ryobi power tool battery, and it's not a brand name cell, it's aftermarket cells. Even though it's a high discharge cell, but it's aftermarket. At this point, I'm very disappointed. The reason why I bought this is because I need some 2.5 amp hour 18650 cells, and I don't need 2.1 amp hour. I have some 2.5 amp hour power tool batteries that I need to repair. This battery here has a total of 10 cells, and it has 2 bad cells inside. And I cannot use 2.1 amp hour and put it in here. That's not going to work. It's also very dangerous. I'm going to talk about that in a separate video, but in short, it must not be done. It's dangerous. So at this point, I think I'm not going to disassemble the cells anymore, because I have no use for 2.1 amp hour cells. I can't use it to repair my batteries here. So my next step is to test the capacity of these cells to make sure that they're supposed to have 2100 milliamp hour at least. And I'm going to use my Opus charger to test the capacity. And yes, I can test the capacity without removing the cells, and I'm going to show that to you next. Let's first check on the voltage of the cell, make sure that they are balanced, and they should have the same voltage. So right now we have 3.8 volts for all the cells. So here's the plan. Because this battery is a 2P battery pack, meaning 2 of the cells are connected in parallel, I can only test 2 cells at a time, which is fine. So the capacity instead of 2.1 now should be 4.2 amp hour for 2 cells. And I'm just going to randomly pick any 2 cells in here, and I'm just going to choose this first because it already has a terminal sticking out, so I can hook it up to my alligator clip very easily. On the other side, it's not as easy to hook it up. I can't clip onto anything with my alligator clip, so I'm going to use the balance terminal to connect it. I have a metal pin here. This is actually a pin for a breadboard, and connect right onto this connector here, like so. And then I can connect that to my alligator clip. Alright, I've got it hooked up to my charger here, and I'm going to charge it at 3 amp for 1S. Alright, it's charging. This battery can be charged at 4 amp each according to the data sheet. So 2 in parallel, I can safely charge at 8 amp. So 3 amp charge should be fine. Now that the battery is full, 4.19 volts, I'm gonna hook it up to my Opus charger for this charge test. Alright, I've got it hooked up to my Opus charger, basically just by using the alligator clips and clip them to the terminals, and it's now discharging at 1 amp. Alright, capacity test is done, and I have tested the 2 cells on the negative terminal and 2 cells on the positive terminal, and I have to use 2 different chargers to test them because all the cells are connected in series, and this charger has a common ground. So if I put it on the same charger, it's gonna short out. So that's why the 2 chargers. For the 2 cells on the negative terminal, we got 4072 milliamp hour, tested for 4 hours 5 minutes. Current voltage is 3.24 volts, and it's supposed to have 4200 milliamp hour, so that is very close. I would say within about 97% range. For the 2 cells on the positive terminal, I've got 4189 milliamp hour. Testing time 4 hours 12 minutes. So for this one, it almost got exactly the actual capacity of the batteries. So what did I learn from this aftermarket power tool battery? 2 words: caveat emptor, meaning buyer beware. This is a totally misrepresented product. This is not 5 amp hour battery, and it is used. The plastic case might be new, but the battery cells are used. Even though they put in good brand name cells, and I can confirm it through my capacity test, I'm not happy with this purchase. That might be because I cannot use it the way I intend to use it for. All of the power tool batteries I have are either 2.5 amp hour or 2 amp hour. I have nothing that is 2.1 amp hour. So what I'm going to do with this particular battery is I'm going to reinstall the BMS and put it back together. I'm going to use it for my 36 volt electric bike or electric scooter. This will give me an extra 5 miles of range. So for $30, I think I got what I paid for. So be careful when you buy a cheap aftermarket power tool battery on the internet, because it might be too good to be true. And that's all for now. Thanks for watching. We'll see you next time.